Guys, coming at you with a riveting video about math. This is a video in the series of videos for geometric proofs. The goal for this series of videos is to just cover the vocabulary or the properties that you will encounter in geometric proofs one by one. This is not an all-encompassing video on proofs. It is an introductory video at best, but we're talking about a specific property. Please respect, proofs are very, very difficult to get right, but it's an important life skill. We're talking about making logistical arguments, backing them up with facts, stuff like that, that are seriously in need in the real world. So in this case, we're going to be focusing on the midpoint property and what it does. First, we're going to talk about what congruency is. We're going to look at the 5 congruency postulates for triangles. Then we're going to talk about what the midpoint property is. Then I'll show you a short example. Okay, let's get started. So first, congruency. Congruency is just saying identical or exactly the same in every way. The difference between congruency and equivalence is talking about a numerical value, where congruency is talking about a physical concept, usually. So these two triangle monsters are the same in every way. Okay, let's take a look at the 5 congruency postulates. So here are the 5 congruency postulates. You have side, 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 which is stating these triangles are the same because you have 3 pairs of congruent sides for the triangles. Side, angle, side, these triangles are the same because we have 2 pairs of congruent sides and 1 pair of congruent angles included within those sides or in between those sides. Angle, side, angle, which states these triangles are congruent because I have 2 pairs of congruent angles, then a pair of congruent sides in between them. Angle, angle, side is stating that these 2 triangles are the same because of the 2 pairs of congruent sides. Then there's the one side that is outside or not included in those 2 pairs of angles, stating that those triangles are the same. Then we have hypotenuse leg, which could only be used in a right triangle. This here is the hypotenuse, which is the longest side of a right triangle. Then I have the legs, which are the other 2 sides. Okay, next, let's talk about midpoint. So here's the midpoint property. I want to say formula. Midpoint property. The midpoint property is kind of pretty straightforward. All it's saying is that if you have a midpoint, or the midpoint of a segment, is going to create 2 congruent parts from that segment. So we got these guys on this really exciting seesaw here, and here's the fulcrum. Well, the fulcrum is exactly in the middle, okay? As a result, this length of the fulcrum, or this length of the beam, and that length of the beam are the same length. So this fulcrum, we could say or argue, is at a midpoint of the beam that the 2 critters are sitting on. Okay, they weigh the same, so they're not really having a fun time. Well, this guy is, not that guy. Okay, let's look at an example of how midpoint property is used in a proof. All right. So this, in order for me to get this one to work, I had to give us a lot of givens here. So let's go through it. First thing it says is that AC is congruent to BC. So AC is congruent to BC. I'm going to mark that off. And I know that because they gave it to me. So that's given. Then they told me angle A is congruent to angle B. I know that, which is these 2 angles, because it's given. They wrote it right here. They had to give it to me. Then it says D is the midpoint of AB. So D, this point here, D is the middle of those points. That is also given. Okay, now let's look at what that's telling us. If D is the midpoint of AB, so D is the middle of this line here. If D is the middle of this line, that means that this part and this part are congruent. If you think about it for a second, it makes total sense. If you go to a 10-inch line and go to the middle of 5 inches, each side is 5 inches. That's what this is saying. This is the middle, so that means this here and this here are the same exact lengths. So this is the same length as that. So I can say now that AD is congruent to, I'll say BD, because of this. So typically that's written as, they say, the midpoint property. So midpoint property. If, for whatever reason, you're not certain about how to word this, just copy the given here and just say D is the midpoint of AB. It's totally viable. It backs up this argument here. Now, I look at my triangle and I want to prove that the triangles are congruent. Well, I have a side here. This is an angle, and that's a side. Looking at that one. Looking at this one, side, this is an angle, and that's a side. Okay, so I can state that the triangles are congruent because of side, angle, side. Okay, and that is how we use the midpoint property in our favor to prove these two triangles are congruent. Okay, guys, I hope you guys found this video on geometric proofs using the midpoint property helpful.